Welcome to Tech with Damir. In this video, we are going to learn about math functions in PySpark. There are a lot of them, and in this demo, I'm going to use few of them that mostly people use it. So here's my sample data. You can see right here, we have some values here, and the columns for this sample data, I have ID, value, and offset. Here I'm creating a DF by using a spark.create data frame and then using this sample data and then using these three columns. Once we will create the data frame, then we can use the df.show to see the data. So if we go ahead and execute, it's going to show us our data frame, and here it is. Not really fancy. We have simple ID, value, and offset. You can see the value for offset as well, and there are some values here. Now I'm going to walk you through a little bit all those math functions, and then finally we'll run the whole thing and take a look on them. So here you see that if you want to find the absolute value, that you can use it. So you will say df.select. So we are using select function here to display our columns, and here is ID that's coming from our data frame. No, I'm not applying any math functions on ID, so ID will come as is. Then I'm saying absolute ABS, and then here is the column on which I would like to put absolute value or calculate absolute value for. So here is the absolute column math function, and then you will put the column inside. We are aliasing that column called the absolute offset, and then we are doing a show. So if I will go ahead and execute this one, you will see the values there. So this is our original data frame. You see ID, value, and offset. Here is the absolute value for our offset. You can see that the value has changed from minus 3.5 to the 3.5. That's absolute value, and for 0 doesn't really change anything. For positive numbers also didn't change anything. So you can see that that's how it will print values for you for after applying absolute math function. Now you can find square root. In this case, same. I'm selecting ID, then applying square root on column value, and it's going to calculate the square root of that value column, and then we are seeing as a square root value column. Then I'm going for ceilin and round up to the nearest whole number. So if you need to do that, you will be using a CEIL and or ceilin, and that will be exactly the same way we are doing absolute, square root, and here you will say CEIL and then provide the column on which you would like to apply this function, and then alias as a name. So, and if you want to do round down to the nearest whole number, you can also use floor, and the floor function will do this trick for you and give you the round down to the nearest whole number. If you want to be like round to the nearest and decimal places, then you will say round, and then you will provide the column here, and then how many decimal column digits you want after that. So you can round according to that. So you can put 1, 2, 3, whatever, so it is a scale that you would like to put there. If you want a banker's rounding, then that's also possible. So you can do that with the round and column value, and then say 1 or 2 or whatever the values. So you can take a look from there as well. So look at the more detail on the documentation, and you can work accordingly. So if you this is for exponential values finding, you can say exp column here, and then for natural logs, you will say log and find the log for that column. Then you have log base 10 if you want to do that, so you'll say log 10, then the column on which you would like to apply this formula, and then you have power. If you want to calculate the power, then you will say power of that column, then you say column offset value, and then you say value power offset. So you provide two places here, so you are going to put power first here, then the second column right here, or value, hardcode value can be provided as well. You have trigonometric functions like a sine, cos, tan, and all that available. So you will say df.select, then select the column just without formula that we would ID, we don't want to apply that. Then here is the formula for sine, and then we alias as a sine, and then you have for cos, and then you have tan and all that as well. So here if you want to find a degree, and or radians, then you can use the degree or radian, and then put on the column on which you would like to apply, or you can hard code the value as well if you like. So I'm going to go ahead and execute this entire notebook, and then I'm going to show you some values. So honestly, this is not really going to be like anything fancy. We are just calculating some math values here, you know, by applying those math functions. So this was our original data frame. Here we calculate the absolute value. Here we find the square root. So you can see right there. So the values from the original. So this was value, we find the square root. So 29394, that's the value came out of it. And then you have ceiling, so you can see the ceiling value, floor, and then around to 1 decimal, you can see right there. Then you have bankers rounding to 1 decimal, so you can see right there. So you have a exponential, and then you have a log and a natural log or base 10 log, and then you have a power, you know. So then you have sine, cos, and tan as a trigonometric functions. Then you have radians and degrees. So you know, you can find all those in the, if you need to do angle conversions, so you can do that as well. So these were just few of them. I just put that like how to use it, at least you can know that, like, you know, it's very simple. You will use the math function, and then you provide the value on like one column, which column you would like to apply those functions. So I thank you very much. Experiment few more, and there is a documentation I will put in the description. You can go through all of those math functions that you need and apply according to your needs. Thank you and have a good one.